Hi, welcome back to MKF. Now today's our topic is analysis of filth in a food part 2. Those who have not watched my part 1 video, I have given link below. Please watch. Now let us start the video. Now analysis of filth in a food product. So first we have to start the sieving process. So for the seafood industry or any food industry, it is advisable to always choose a sieve dye, because for example in seafood or shrimp industry we have to take 2 to 3 lb of shrimp samples for the filth examination. So 2 to 3 lb means 1 kilo to 1.2 kilo or something like that. 8-inch dia of sieve is not advisable, so the congestion. So always choose 12-inch dia as per the guidelines also says. You take the 12-inch dia of sieves, two numbers. One is 8 mesh sieve and the second one is 140 mesh sieve. Two different sizes you have to take. Depends upon the filth fragments. Doing the analysis, you can choose the sizes of the sieves. Yes, 8 mesh sieve should nested on 140 mesh sieve. Then the slab placed or the product samples of 2 to 3 lbs placed on a 8 mesh sieve. If you have chilled water facility, then splash the water on surface of the shrimps or surface of the fish for the complete thaw of the glaze or complete remove the ice. Then you can observe after thawing, if they have the chilled water facility, you can directly spray the water forcefully on the material. If you don't have chilled water facility, and you can as a ice cubes, you can use it as a ice cubes. Once the slab is completely thawed, and remove the thawed shrimps from the 8 mesh sieve and observe the any macro filth which is found on 8 mesh sieve. If not there, then if whatever the residues are there, you can gently transfer by washing the side walls of the 8. With the help of wash bottle, you can gently wash the side walls of 8 mm mesh sieve of 12-inch dia, and transfer the liquid into the transfer the macro filth or something onto the 140 mesh sieve. And then with the help of wash bottle, distilled water, gently wash the walls of the 12-inch dia of 140 mm mesh sieve and collect the filth into the beaker carefully by washing or by rinsing the walls of the mesh sieves and transfer into the beaker. Once you transfer the beaker, that is the sieving process is completed. Then we will go for flotation methods, because the flotation method is very advisable, because the insect fragments or cockroach fragments or rat hairs or human hairs or barbules are all oleophilic in nature, which can float on the surface of the solution, the surface of the oily solution, which can easily float. So for that purpose only we have to add the heptane. So once you transfer, see this is the example of Erlenmeyer flask. So rinse the walls of sieve to collect all residues and transfer to the Wildman trap flask, or from beaker you can transfer to the Wildman trap flask. In the Wildman trap flask, make the volume of water to about 600 ml and then add 30 ml of heptane. Tilt the flask to about 40 degrees by hand rotate briskly to 200 to 250 strokes per minute. So after tilting, once you add heptane, heptane is a good solvent for non-polar substance like oily and fats. These cockroach fragments or fly fragments all are fatty in nature, oily in nature, which can easily float on the surface of the oily layer which contains heptane, because the heptane is a non-polar substance. So that's why we are adding heptane and tilting the flask 200 to 250 times thoroughly and keep it for this. Once the oily layer float on the surface of the Erlenmeyer flask, with the help of metal shaft, this is called the metal rod, it underneath the stopper. This is the stopper. What you have to do is, with the help of metal rod, the stopper is on the down of the Erlenmeyer flask. Gently you have to move upward the metal rod, so the stopper will come upward and it will trap the oily layer. So this oily layer, the stopper will trap, because we will lift the stopper gently. Then the trapped oily layer will be transferred to a beaker. The filth laden oil interface layers are captured in the neck of the flask. Utilizing a rubber disc and a rod, the oil and the interface layers are cleanly separated from the aqueous phase and removed, poured up from the trapping system. The trapped oily layer, which is floating on the surface, contains filth fragments. So once you transfer the trapped oily layer, 1 centimeter, 2 centimeters oily layer, then after that remove the stopper, and stopper also contains some filth fragments might be. So rinse the stopper carefully and transfer that water also into the beaker. So this is the flotation method. In this flotation method, heptane is used as a good solvent for non-polaric substances like fats and oils. So the insect fragments such a way we can trap with the help of the stopper, moving upward and pour it into the beaker. So this is the flotation method. After flotation method, then the next step, have a look. The final step of most flotation method is to transfer the oily liquid filth, extracted filth, into the long side armed flask, 1 liter flask. So for that we need a Buchner funnel. This is the Buchner funnel. So this is the filter paper, and this Buchner funnel having the screws, the small pores are there. Why the small pores are required for the Buchner funnel? It's a ceramic, so the Buchner funnel have to be rested on the side armed flask. So we have to rest the Buchner funnel is like this, and after this the filter paper we have to put on the top. This side arm we have to make a connection for the vacuum pump, so to create suction. Why do we create a suction? Because while pouring the extracted filth, highly extracted filth on the Buchner funnel, so once you start the suction, which will generate vacuum. So the Buchner funnel having small pores, so which will uniformly, evenly maintain the pressure, vacuum pressure, so that once you pour the extracted oily filth on the filter paper, the filth also, once we pour the oily extracted filth on the filter paper, the filth also distributed evenly on the filter paper. The main purpose of the vacuum creation is to enhance the filtration process, to speed up the filtration process, so that the liquid also will fastly filter and the residues of filth fragments remains on the filter paper. This is the procedure, that is the purpose of the side arm flask, to connect the vacuum pump. Then take out the filter paper from funnel, then moisten with 1:1 alcohol and glycerin. Then viewed under stereo microscope with a magnification of 30x. 30x magnification is enough to view the filth fragments. With the help of reference specimens which we have already prepared. So we have to observe and compare with the reference specimens. So that is about the complete procedure of examination of filth fragments in food products. Now the sampling scale for filth examination in a food product. Yeah, the sampling scale as per FDA guidelines, for every lot or batch or for everyday production, 6 subsamples can be collected randomly, and there should not be composited of each subsample. Now regulatory tolerance limit of filth. Flies whole or equivalent fly fragments. Disease carrying 2 in sample. Other insects 3 of same species. Then insects fragments. Disease carrying insects 5 fragments present in at least 2 of 6 subs. Rejectionable. Then cockroach whole or equivalent fly fragments. Large body parts of disease carrying insects 1 in at least 2 of 6 subs can be rejected. Then hair rat or mouse whole or equivalent. Rat or mouse average of 1 per sub. Any size are striated but not rat or mouse average of 4 per subs any size. So that is about the regulatory limits or tolerance limits of the filth in the food products. That's all about the video, friends. Thank you for watching the video. If you like the video, click the bell icon and subscribe my channel for regular updates. Thank you and bye bye.